Okay, so moving on to section 7 of chapter 17, we're going to talk a little bit about blood transfusions. So, our cardiovascular system typically acts to help minimize the effects of blood loss by doing two different things. One is actually reducing the volume being sent to the affected blood vessels, and the second would be to increase the production of red blood cells or increase the rate of erythropoiesis. So even by doing those two mechanisms, our body can only compensate for so much blood loss. So about 15 to 30% of blood volume loss can cause pallor and weakness. If we lose more than 30% of our blood volume, this could potentially be fatal. So again, if we have really, really low blood volume, it can result in shock, which can lead to death. So in the event that we have massive amounts of blood that we're hemorrhaging and we can't get a transfusion quickly, then we want to go ahead and replace the blood volume with something like normal saline or a multiple electrolyte solution, something like Ringer's solution. And the whole purpose of those are to help mimic the plasma electrolyte composition. But if we replace it with the saline or an electrolyte solution, that's only going to restore the volume of blood. It's not going to help replace the red blood cells that we actually lost. So it doesn't help replace the oxygen carrying capacity of our blood cells. So when we're transfusing red blood cells, we have whole blood transfusions. These are rarely used, and they would only really be used if we're losing massive amounts of blood very, very quickly. Normally, the transfusions are going to be with packed red blood cells, or PRBCs, and this is going to be whole blood, which has a lot of the plasma and the leukocytes out of it. So those have been removed. If we're talking about blood banks, if we're going to go through and do donate blood, they usually separate the donated blood into compartments. Also, we're talking about shelf life of blood only being about 35 days. So human blood groups of the donated blood has to be predetermined because transfusion reactions can be fatal. So if you receive an infusion of a different blood group than your own, it can be incompatible, leading to fatality. So blood typing is going to determine the blood groups. So people have different blood types, and like I said, if we get a transfusion of incompatible blood, that can be fatal. So in the plasma membrane of all red blood cells or erythrocytes, we have these little markers that are called antigens, several different types. And in general, we call an antigen something that can be perceived as foreign. And if we perceive something as foreign, that typically is going to generate or mount some sort of immune response. If we're talking about antigens or these things that can generate an immune response on a cell, we're specifically talking about a red blood cell, then we call them agglutinogens. Okay, so the antigens that are on the red blood cell membranes are called agglutinogens because they're able to promote agglutination or clumping. So if we get a mismatched transfused blood, that's going to be perceived as foreign and cause agglutination and could potentially be fatal. So if we're talking about human blood groups, we do have at least 30 naturally occurring antigens or agglutinogens on the surface of our red blood cells. The presence or the absence of each antigen type is going to be used to classify the blood cells into these different groups. Some blood groups, such as M&S or Duffy or Kell or Lewis, they're only weak agglutinogens, so they're not usually typed because they don't normally cause or generate an immune response. Antigens of the ABO and the RH blood groups, those are going to be the ones that cause the most vigorous transfusion reactions, and so those are the major blood groups that we actually type. So let's start with ABO blood groups. So these are based on whether or not we have the presence or the absence of two types of agglutinogens or those antigens, and that would be type A and type B. So depending on which of these a person inherits, he can either have ABO blood group will either be A, B, AB, or O. If we're talking about the O blood group, that means that it doesn't have A or B agglutinogen. And the most common ABO group in North America is actually blood type O. If we're talking about type AB, that means it has both A and B agglutinogens, which remember are also called the antigens. And if we're talking about type B, that has only the B agglutinogen. And if we have type A, that has only the A agglutinogen. So the blood may contain preformed anti-A or anti-B antibodies. The antibodies we will call agglutinins. And these basically act against transfused red blood cells with the ABO antigens that are not present in the recipient's RBCs. So after about 2 months of age is when we start forming the antibodies or the agglutinins against the antigens that we don't have on the surface of our red blood cell. So I think the best way to kind of understand this is by looking at this table. So if we have blood group type AB, again, that means we have the A antigen and the B antigen on the surface of our red blood cell. So here's the A antigen represented as a little triangle, and the B antigen is represented as a circle. Because we're talking about antigens on the surface of a red blood cell, we call them agglutinogens. So because we have the A and the B antigen on the surface of a red blood cell, and if we have blood type AB, that means we don't want to produce any antibodies against these antigens, or else we would be attacking our own blood cells. So we have no antibodies, which are also called agglutinins. Now, if we have blood type B, that means that we have B antigens on the surface of our red blood cell. So we can see the little circles that represent the B antigen or agglutinogen. After about 2 months of age, our body is going to naturally produce the antibody against the A antigen. So we have anti-A or antibodies against the antigen A. We don't have the A antigen, so we would not be attacking our own red blood cells. If we have blood type A, that means we have the A antigen, so now we have the triangle antigen on the surface of our red blood cell. And remember, antigens are also called agglutinogens, so we have the A agglutinogen. Our body, after about 2 months of age, will begin producing antibodies against the antigen B. Because we don't have the B antigen, we can produce antibodies against it. So blood type A has anti-B antibodies or agglutinins. If we have blood type O, that means we don't have any of the antigens, A or B, on the surface of our red blood cell. So you can see that. However, because we don't have the A or B antigen on the surface of our red blood cell, we're going to produce antibodies against both of those antigens. So floating around in our plasma, we're going to have anti-A and anti-B. So that's why we have O as the universal donor. O is the universal donor because it doesn't have any antigens on the surface of its red blood cell. So it doesn't matter if we give type O blood to type AB, B, or A, even if they have the antibodies against the A antigen and the B antigen, they can't attack it because there's no antigen for the antibody to recognize. There's nothing on its surface. Blood type AB is considered the universal recipient. Because there are no antibodies in a person's blood that has blood type AB, it doesn't matter which blood type they receive, there's not going to be antibodies present in the blood for it to go in and attack and recognize the other blood type as foreign. So the ABO is one of the blood groups where we're describing, again, the A and B antigen being present or not present on the surface of a red blood cell. But we also have another antigen or agglutinogen, and that's the Rh factor. So there's about 52 named Rh agglutinogens, each of which we call an Rh factor. Only 5 of them are really common, so you might have heard of them, C, D, E antigens. But when we're talking about the Rh blood typing system, it's named because of one Rh antigen, which is specifically the agglutinogen D, or the D antigen here. It was originally identified in a rhesus monkey, which is why it's called the Rh antigen. And then later we found out that humans also have this antigen, can have this antigen on the surface of their red blood cell. So if we're looking at Americans, about 85% of Americans are Rh positive, meaning they have the Rh antigen on the surface of the red blood cell. So only about 15% of Americans do not have the Rh factor. The difference between the Rh blood groups and the ABO blood groups is the antibody formation. So if we're talking about A, B, and O blood type, our body after 2 months is naturally going to produce the antibodies against the antigens that our red blood cells do not have on their surface. If we're talking about the Rh antigen, our body does not naturally produce the antibody against it if we don't have it on the surface of our cell. So the anti-Rh antibodies, they are not spontaneously formed in an Rh negative individual. So if we're talking about anti-Rh antibodies, form only if the Rh negative individual receives Rh positive blood, or if mom is carrying an Rh positive fetus. So the second exposure to the Rh positive blood would typically result in a transfusion reaction. Okay, so we have hemolytic disease of a newborn, also called erythroblastosis fetalis, and it occurs when we have an Rh negative mom with an Rh positive fetus. So what happens is that her antibodies can cross the placenta and actually go to attack and mark as foreign the baby's red blood cells, and it produces this condition. The baby can become anemic, hypoxic, and in really, really severe cases, there can even be brain damage or even death if we don't have transfusions done before the birth. Let me see what else I have. So the first pregnancy, if we're talking about this, the Rh negative mom is exposed to the Rh positive blood. So after her first baby is delivered, because the mom has been exposed to the Rh positive blood, she is going to begin synthesizing the anti-Rh antibodies. So her second pregnancy, if she again has an Rh positive fetus, the mom now has produced the anti-Rh antibodies that can go in and flag the baby's blood cells as being foreign. So what do they have to do? They treat it with something called RhoGAM, which is a serum that contains the anti-Rh and can prevent an Rh negative mother from becoming sensitized to begin with. So transfusion reactions. So we get a transfusion reaction when the mismatched blood is infused. It typically is going to occurs in which the recipient's plasma antibodies attack the donor's red blood cells. So the donor cells are attacked by the recipient's plasma agglutinins, and it's going to cause agglutination or clumping, and it can clog those small blood vessels. If we have these clogs in our small blood vessels, they can cause the rupture and the release of hemoglobin into the bloodstream. If we lose the hemoglobin that's in the red blood cells, that's going to limit our ability to carry oxygen. It's also going to decrease blood flow beyond the blocked vessel. So if we have a clot, we can't, supply the tissues after that clot. And hemoglobin in the kidney tunnels can also lead to renal failure. If you have some sort of transfusion reaction, again, if you receive the wrong blood type, your typical symptoms are things like fever, chills, low blood pressure, and a rapid heart rate, sometimes nausea and vomiting. The treatment is really acting to help prevent kidney damage, so take in a lot of fluids, take some diuretics to help wash out the hemoglobin that has been lysed out of these cells. Again, type O, that's going to be a universal donor, so they don't have any A or B antigens. AB is the universal recipient, meaning that their blood does not produce the antibodies against antigen A or antigen B. So blood typing. So in order to type the blood, basically the donor blood is going to be mixed with antibodies against common agglutinogens. If a agglutinogen is present or an antigen is present, you're going to see agglutination. So you're going to see clumping. So blood is going to be typed for A, B, and O, as well as the Rh factor, because those are the major causes of agglutination. We also have cross-matching, which is typing specific donor with a specific recipient. Mixed recipient serum with the donor red blood cells, and mixed recipients red blood cells with the donor serum. So this is an example of blood being tested. So we have type AB. Blood basically put and assume two different wells. If this is blood type A, here's anti-A right here. We have blood type A, so we would expect to see this clumping that's occurring. Blood type AB with the antibody against B antigen would also cause agglutination or clumping because those antigens are present. If we have blood type A, that means we only have the A antigen, so we would expect the antibody against A to come in and attack it and cause clumping. But we don't have the B antigen, so the antibody can't attack the blood there. If we're talking about blood type B, it's the opposite. We do not have the A antigen, so we wouldn't see clumping when we administered the antibody against the A antigen, but we would see clumping when the antibody against the B antigen was administered. And blood type O, it doesn't have either antigen on the surface of their red blood cells, so we wouldn't expect to see any clumping regardless if we added the antibody for A or the antibody for B.